Hello everyone, this is Bhumika Mohan. In this video, I am going to talk about a research related to artificial intelligence, that is AI in problem solving, a multidimensional analysis research. The contents of this video are: first, I'm going to talk about abstract, then introduction, literature review, methodology, outcomes, and then in the last, its conclusion. Coming to the abstract, the paper aims at more comprehensive understanding of AI in complex problem solving, where there is usually a multiplicity of interrelated variables and choices bound by time. Research has shown that affective, cognitive, metacognitive, and social processes are required for solving complex problems. However, how AI can support these processes remains somewhat underexplored. Total of 38 recent studies were reviewed by scoping the study to find that human AI collaboration in the solving of complex problems seems to be a hot topic that is generating interest from multiple disciplines. In general, most significant developments have been made in the cognitive domain, though increments are also appearing in social and affective domains. Furthermore, the paper addresses the greater challenge of what is to be understood by intelligence, whether human or artificial, by proposing harmonized abstract and operational definitions of intelligence that highlight the ability to attain new goals through perceptual cognitive processes in the case of humans and computational ones in the case of AIs. Along with this, a multidimensional model of intelligence is envisioned and a call for better AI evaluation methods is proposed through AI metrics to make sure one gets credible and valid assessments of system performance. The paper concludes that current AI systems show artificial achievement or mastery rather than true intelligence. Lastly, it calls for interdisciplinary collaboration and refined measurement practices to try to bridge the two, that is, artificial and human like. Coming to introduction, the introduction mentions the never-ending search in psychology and computer science for definitions of the human and artificial intelligence. This endless quest for defining terms has left some research quite fragmented, contributing to the lack of interdisciplinary work between these fields. By scrutinizing these seeming inconsistencies in definitions, this paper will critically examine the nomenclature that can bring these fields together to call out for more appropriate research and scientific discoveries. The nature of the problem, too, has changed due to the modern developments as the interdependence and globalizing nowadays make complex problems more burdensome. The development of AI, cognitive psychology, and computational technology pushes forward a different approach by the individual and the team to the real life problems of life. Given such advances, AI can process a lot of data and support collaborative problem solving by improving cognitive, social, and affective processes, hence becoming the keystone for developing with complex real world solution challenges. Further layers of complexity arise as problem solving becomes much more collaborative with increased integration in AI. The nature of AI has recently shifted from automation to a means of augmenting human abilities for the more sophisticated human AI interaction. But huge gaps remain in understanding how AI can support human collaboration, especially in terms of the social, metacognitive, and affective dimensions of teamwork. This paper, based on a review of the more recent empirical evidence on AI's role in supporting human complex problem solving, bridges this gap by focusing on how AI enhances social, cognitive, and affective processes in teams involving humans and AI. Coming to the literature review of this paper, the paper focuses on the role of artificial intelligence in supporting complex problem solving and the ongoing challenges in defining what it means to be intelligent, both humanly and artificially. In doing so, a coping review of the paper considers the ability of AI in enhancing the solving of complex problems involving dynamic, real world challenges involving multiple variables and demanding prompt decisions. The scoping review points out that contributions to problem solving processes had mainly been on the cognitive process, while support for the metacognitive, social, and affective dimensions has received less attention. AI would also be of great help in improving human collaboration in complex problem solving by analyzing huge data sets, providing real time insights, insights, and hence influencing the decisions of humans. The extent to which human influences human AI teamwork in complex settings, though still vague, is definitely less clear in areas beyond pure cognition. It also pertains to the long debate raised in both fields, psychology and computer science, around the definition of intelligence. The literature presents an inconsistency between the ways human and artificial intelligences are conceptualized, thus serving as fragmentation in research efforts on both sides. In this paper, intelligence is defined in a unified framework considering both human and AI capacities to achieve novel goals through cognitive and computational processes. It also stresses the need for developing standardized measures akin to psychometrics that would help one measure AI systems in a more meaningful and interdisciplinary way by closing the human to artificial intelligence divide. These reviews highlight the significance of AI in human problem solving and indicate an important need to develop uniform definitions and evaluation frameworks that are tailored to better interdisciplinary comprehension and understanding of intelligence transversally across domains. Coming to the research methodology of this paper, this research study uses a scoping review methodology to answer two interrelated themes: the role of artificial intelligence in supporting complex problem solving and definitions of intelligence in human and artificial contexts. Scoping review of AI in complex problem solving. The first step requires a literature based scoping review in empirical studies over the last 5 years on how AI supports complex problem solving. Systematic search strategy focusing on articles published in multiple academic databases and filtered for the relevant articles based on specific inclusion criteria, namely studies related to the application of AI in collaborative settings. A total of n equal to 38 studies into how AI is augmenting cognitive, metacognitive, social, and affective processes in problem solving was coded and subjected to thematic analysis. The findings have been synthesized to present key gaps in the understanding of human AI collaboration, especially regarding how social and emotional factors might interact with teamwork. Definition of intelligence. In this stage, existing definitions of intelligence in psychology and computer science are evaluated critically. In this approach, inconsistencies and conceptual fragmentation in the definition of human and artificial intelligence are identified based on established literature. Using a structured methodology, different definitions and frameworks are categorized into one unified nomenclature to communicate and share results between disciplines better. Integration of findings. This combines insights from a scoping review with analysis of definitions of intelligence. The article aims to construct a unifying framework that addresses the complexities of human AI collaboration in problem solving in such a way that can engender interdisciplinary dialogue, improve research, and further support the development of standardized metrics for the evaluation of AI systems. It has, through this dual methodology, been designed to fill in the huge gap between what human minds perceive as intelligence and what artificial minds can be made to compute of intelligent behavior while pushing forward the understanding of AI in its context of complex real world challenges. Here are the outcomes. The analysis of the research provides rich insights into the role of AI in complex problem solving and the abstract difficulties posed by defining both human and artificial intelligence. N equal to 38 studies suggest that AI technology has resulted in tremendous improvements in human performance for complex problem solving activities. AI systems can efficiently augment cognitive processes because they are capable of producing insights from vast chunks of data and providing real time decisions, mainly in high pressure and dynamic conditions. However, metacognitive, social, and affective aspects of support for AI still requires research. The key gap identified in the review surrounds understanding the ability of AI to enhance teamwork, emotional regulation, and group dynamics while often integrating AI tools into collaborative problem solving settings. Overall, according to the results, AI has not reached its full potential to augment human capabilities beyond cognition, specifically regarding enhanced collaboration and social interaction in problem solving contexts. Definitions of human or artificial intelligence are generally missing in consensus from psychology and computer science. The survey found a lack of cross cutting consistency. For the most part, human intelligence is perceived as being quite perceptual cognitive, while artificial intelligence is viewed mainly in terms of computational abilities. Conceptual fragmentation hinders interdisciplinary work and the formation of coherent theoretical frameworks. To this, the findings suggest a more specific nomenclature that brings uniformity to the meanings of intelligence in both domains by focusing on the ability of new goals attainments through respective cognitive and computational processes. Additionally, the research calls for the development of standardized assessment frameworks akin to psychometrics that will help guarantee the proper assessment of artificial intelligence systems and consistency in their performance. The results also strengthen further evidence of shared variance between human general intelligence, that is G, and artificial and general intelligence, that is AGI, indicating that two different intelligences share an understanding of the multidimensional model of capabilities. This shared framework would allow for interdisciplinary collaboration to be more precise and meaningful, at least when designing AI systems to mirror close to the intelligent human like model. In conclusion, these are the fruits of such investigations, reflecting an ever widening scope of opportunities for AI support in solving highly complex problem situations, while at the same time they also call for a balanced and concerted approach to formulating a common standard of intelligence among psychology and computer science. This is important for further development in AI systems that complement human intelligence, encouraging innovation to achieve better collaboration in problem solving situations. Here is the diagram that is related to domains of human AI collaboration. Here it shows metacognition, affective, cognitive practices, and social practices. Coming to the conclusion, the analysis of the studies highlights the significant potential of artificial intelligence, that is AI, to support human problem solving, particularly in complex and dynamic environments. Additionally, AI excels at enhancing cognitive processes. However, research remains necessary to discover the utility it can offer for the social, metacognitive, or affective dimensions of the problem solving process. The challenge to articulate how both human and artificial intelligence stand across various disciplines into one definition persists as a hurdle towards the cohesive pursuit of study and innovation. It requires a unified, multidimensional model of intelligence that not only includes cognitive ability but also computational capacity to bridge the gap between human and artificial perspectives in more efficient collaboration and with advancements in AI systems reflecting human like intelligence. Thank you.